Welcome back to a new chapter, starting chapter 3 now. And chapter 3, we'll be looking at quadratics and some rational functions and some things like that in this chapter. So, um, lots to go in this chapter, but a lot of it we've covered in first semester, so don't be anxious about that. We started yesterday with adding, subtracting, and multiplying complex numbers. You didn't seem to have a trouble with that, so I thought I'd wait and do a video today when we were doing dividing and simplifying those complex numbers or powers of I. When you simplify powers of I, they go in a pattern. I to the first is I squared, when you simplify it, is -1. And that's something that's important. You remember yesterday I circled that on your paper. I squared is -1. I cubed is -I, and I to the fourth is 1. And then you can continue I to the fifth, and sixth, and seventh, and eighth, and ninth, and 10th, and 11th, 12th. And every time you have a multiple of 4, you end up back here at the top. So if I want to do I to the 15th, I can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I to the 15th would be -I. I to the 12th. Now I can count, or you can know that 4, 8, 12. I'm going to end up right up back here at the top. I to the 12th would be 1. I to the 6th would be 4 plus 2, so I'd get -1. And I to the 83rd, that's a lot of counting. You can do it if you'd like to, or you can know that what's a multiple of 4 that'd be close to 83? Well, 4 times 20 is 80, so if I multiply times 20, I'd end up here at 80, and then 81, 82, 83. My answer would be -I. And so that works in a pattern, those powers of i's. So you should be able to do the problems that ask you to simplify that. I think one asked you to do something like this. It said something like, what is 5i to the fourth? When you raise a power to a power, both of those numbers are actually raised to that power. So this is 5 to the fourth and I to the fourth. And 5 to the fourth is 625, and I to the fourth, let's look on here, is 1. So 625 times 1 would be 625. You may have ended up with, if it was to the third, you could have ended up with an I in your simplified answer, but you just have to remember to do the power to both factors of that product. Okay, now let's get to some simplifying these expressions. When you have uh, a fraction that involves an imaginary number, we have to get rid of the complex numbers that are in the denominator. That is not okay when you're simplifying. So we multiply by what's called the conjugate. That will cancel that imaginary number out of the denominator. And if my original number is 2 plus 3i, then I'm going to multiply 2 by 2 minus 3i. Notice I didn't say the opposite. It's not the opposite because I didn't change the sign of 2. I only changed the plus to the minus, so it's called the conjugate. So now I have to multiply. If I multiply 5 times 2 minus 3i, that's 5 times both things. 5 times 2 is 10, and 5 times 3i is 15i. And then on the bottom, I've got 2 plus 3i times 2 minus 3i, so I've actually got to do the distributive property or FOIL. 2 times 2 is 4. And when you do this, your outers and your inners are going to be opposites of each other. 2 times a minus 3i would be minus 6i. 3i times 2 would be plus 6i. See how those are opposites of each other? And then your last, plus 3i times minus 3i is minus 9i squared. On the top, there's nothing I can do, so I leave it 10 minus 15i on the top. On the bottom, these cancel, so I have 4 minus 9i squared. I squared is -1, so minus 9i squared would end up being plus 9, because minus 9 times -1 is plus 9. So my answer to this problem would be 10 minus 15i over 13. Let's look at another example. Make it a little bit more difficult. If I have a binomial on the top and a binomial on the bottom, well, all I'm concerned about is the bottom. I can't have that I in the denominator, so I'm going to multiply by the conjugate, the complex conjugate, and I have to do that on top and bottom. That's like multiplying by 1. It doesn't change the value of my fraction. So since it's a binomial times a binomial, I have to do FOIL on the top and the bottom here. All right, out first, 5 times negative 7 is negative 35. The outer would be minus 10i. The inner would be plus 7i because it's a negative I times a minus 7. And then the last would be plus 2i squared. On the bottom, negative 7 times negative 7 is 49. The outer would be plus 14i. The inner is minus 14i. And then the last would be minus 4i squared. Okay, so now if I combine my like terms here on the top, I'd have negative 10i plus 7i, that'd be minus 3i, and then this plus 2i squared becomes minus 2, because again, I squared is negative 1. And on the bottom, I'd have 49, and these would cancel, and minus 4i squared would be plus 4. So on the top, it'd be negative 37 minus 3i, and on the bottom, it'd be 53, and that would be my answer. Next is one that involves a radical. So I've got to multiply by the complex conjugate. I'm going to multiply by 5 plus 4i on the top and the bottom. And on the top, if I it's going to be FOIL again, or distributive property. 2 times 5 is 10 for my first. My outer would be plus 8i. My inner would be plus 5 squared root of 3i. And my last would be plus 4 squared root of 3i squared. On the bottom, 5 times 5 is 25. My outers would be plus 20i. My inners would be minus 20i. And my last would be minus 16. I almost wrote 8. 16i squared. That's a 16. Okay, so the top, the only thing I can do is rewrite it. And since the last one is plus 4 squared root of 3i squared, I'm going to rewrite it as minus 4 squared root of 3. On the bottom, it's going to be 25. These cancel, and that would be plus 16. So all I'm going to do here, and it wouldn't be wrong if you didn't, but I'm going to move the real numbers to the front and the imaginary to the back, just to rearrange it. 10 minus 4 squared root of 3 plus 8i plus 5 squared root of 3i over 25 plus 16 is 41. And that's how you do that problem. One more. It involves a fraction with a common denominator. When you have fractions with common denominators, you can put them together as a single fraction. So I can rewrite this 9 plus 4i over 1 minus I. 3 plus 6 give me 9, 2i and 2i make 4i, and if it's over 1 minus I, you keep that common denominator. So now I multiply by the complex conjugate, 1 plus I on the top and the bottom. And on the top, I do first 9, outer 9i, inner 4i, last 4i squared. And on the bottom, I do first, which is 1, outer, which is plus I, inner, which is minus I, and last, which is minus I squared. So on the top, I get 9 plus 13i minus 4, and on the bottom, I'd get 1, and these would cancel, plus 1, which would be 5 plus 13i on the top and 2 on the bottom. And that is your answer. So combine your like terms, write it as a single fraction, and then multiply by the conjugate. Hope you don't have any trouble with today's assignment. Let me know if you do.